Machines. They form the backbone of our lives. From the moment we wake up, we can't help but stare at them. We want to get from point A to B, they tell us where to go. We want to communicate with family and friends, they act as an intermediary. We want to relax, they steal our attention. We want to go for a run, they track our steps. We go to work, they track our location. At this point, machines are so interwoven into our lives that without them, most of us would be like lost puppies, desperately looking for their owners to put them back in their lead so they can continue to loyally serve their master. Well, good thing machines can't actually think, so they'll never know this immense power that they hold over us.
Could machines ever think as human beings do?
Most people say not.
But can machines think? This is the question posed by Alan Turing in 1950, which in many ways birthed the field of artificial intelligence. Notably, this was just 14 years after he proved that anything which is computable could be computed on an idealized device called a universal Turing machine, if it were given the right inputs. It was this breakthrough idea which allowed for computers as we know them today to exist. It means that if I want my computer to do something new, I can just install new software, instead of needing to buy a new device altogether. But if a universal Turing machine can perform any possible computation, then if thought is a type of computation, it follows that it is possible for a machine to think. So is thought a type of computation? Turing avoids this problem, replacing it with his imitation game. In this game we have an interrogator, a regular person, and an AI system. The interrogator is able to ask questions of the person and the AI system, but they do not know which is which ahead of time. Their goal is to correctly identify which is the person and which is the AI system based on their responses. If an AI system is capable of fooling interrogators, such that they cannot distinguish the AI from a human more often than would be expected by chance, then we can say that this AI has passed the Turing test. Although no AI has unambiguously passed the Turing test today, the rapid improvements being made in language models by groups such as OpenAI, seen in their GPT-3 model, suggest that the Turing test will likely be passed in the coming years. If this is the case, and passing the Turing test implies that machines can think, then it seems as though we are rapidly approaching the era of thinking machines. But is the ability to imitate thought really enough to say that a machine can think? Many would say not, as a machine could thoughtlessly apply rules which are able to deceive us into believing that it can think, without ever experiencing something we would call a thought. However, this raises an even deeper issue. How do you know that people other than yourself can think? After all, you're immediately aware of your own thoughts, but you never experience anyone else's thoughts. From your perspective, how do you know that everyone around you isn't just imitating the ability to think, like machines which pass the Turing test? A common response to this problem claims that you are similar enough to other people to conclude that if you can think, then they can think as well. After all, you have a brain and they have a brain, and since your brain produces thoughts, it seems silly to suppose that theirs does not. Maybe we can take this reasoning further. We are fairly similar to other mammals in a lot of ways as well, and they have brains similar to our own, so it makes sense to suppose that they can think as well. But just how far can we take this? Can ants think? Can worms? How about fungi or plants? Is the key requirement for thinking really the possession of a brain, or can something else which functions in a similar enough way also think? Well, as indicated before, if thought is a type of computation, then machines can think, so a brain is not required for thought. But is thought really just computation? Since we do not know the answer to this for sure, there are a few possible views one may have. View 1 states that everything is computation. Proponents of this view include Stephen Wolfram, who is trying to find a computational theory of everything in physics, as well as those who believe that we could be living in a simulation.
It's hard to argue against the possibility that all of us are not just the creation of some kid in a parent's basement programming up a world for their own entertainment.
If everything in the universe can be described computationally, then so can our thoughts, implying that it is possible for machines to think. This does not imply that the sort of machines we have today can think, but it does mean that it is possible to invent thinking machines. After all, in this point of view, humans are just complicated machines themselves. View 2 states that only some things are computational, and that thinking is one of them. There are good reasons to think that the universe is not fundamentally computational. For example, in general relativity, space-time is continuous, but if the universe was a computation, we would expect it to be discrete. Furthermore, there is an increasing amount of evidence that thought is a type of computation, including advances in computational neuroscience, machines defeating humans in games which were previously considered to require complex thinking, recent success with brain-computer interfaces and neural implants. However, At this point, none of this evidence is conclusive.
What kind of fish performs brain surgery?
I don't know.
A neural surgeon.
View 3 states that only some things are computational and that thinking is not one of them. This is the view argued for by Nobel Prize-winning mathematical physicist Roger Penrose.
I'm trying to say that whatever consciousness is, it's not a computation.
Now you can tell this guy is smart because his book makes a nice thumping sound when you drop it. But why does he think this? Well, he draws on something called Gödel's incompleteness theorem.
Now what Gödel shows is he constructs a very specific sentence. You can see by the way it's constructed that it's true. But you can also see by the way it's constructed that it cannot be proved by this procedure.
Essentially, he thinks we can see certain statements are true, which it would be impossible for an algorithm to prove to be true. Hence our thoughts must be doing something which is non-algorithmic. However, this is a gross simplification of his point of view, and if you want to understand it better, you should read The Emperor's New Mind. So, where does that leave us? 3 views and still no clarity on whether machines can think. Perhaps Turing was right after all. The question of whether machines can think seems elusive, always being just out of reach. But the question of whether machines can pass the Turing test is concrete, and seems to suggest that thinking machines might be just around the corner.
Could machines ever think as human beings do?
Well, the problem is you're asking a stupid question. The interesting question is, just because something thinks differently from you, does that mean it's not thinking?